Today we're talking about the pre-con Chapter 5, Trigonometry. I'm the speaker's Angela. And the first one, we're talking about the basic trigonometric identities. This is the basic things we need to remember. This is the reciprocal identities, and this is the quotient identities. We need to remember and recite. And the second one is, this is extremely important because we need to use it in the later problems. And we can deduce the second and third one from the first one. How can deduce it? The one is equals to the square of cosine theta over the square of cosine theta. Is that right? 1 is equals to this. And so what is the square of tangent theta? The square of tangent theta, as you can see, this is equals to the square of sine theta over the square of cosine theta. And thus we can get this, the square of cosine theta, and the over is the square of cosine theta plus the square of sine theta. And that certainly is the 1. So we look at the formula because this is just the second theta. Second theta equals to 1 over cosine theta. So this is the square of second theta. So you can try it the third one later, and this is pretty important. Please remember it. And the second part, we're talking about the cofunction identities. We have made it in the before class. I'm trying to draw a sine function, and this is an important one. What is a sine? Pi over 2 plus theta. What is this? You can move this graph to the left, and you can get this is equal to cosine theta. And now you can change this because this pi over 2 minus theta, so that you can change it to the cosine minus theta. Because it's a even function, so it's equals to the cosine theta. So this is the reason why it's this one. So that's you can deduce it by yourself. And then the Oem identities, you have learned the sine function, the cosine function, and the tangent function. But what about the cosecant and secant? As you can see from this, cosecant theta is equal to 1 over sine theta. Sine function is the odd function, so the cosecant function is the odd function. And the secant theta equals to the 1 over cosine theta, so it's certainly the even function. After learning some basic knowledge, let's do some practice. But before we do this, let's review some knowledge. A plus b times a minus b equals to the square of a minus the square of b. And this is what we have learned. So use these tools, we can solve this problem. We can prove the left side. And as you can see, we can get this. We can times 1 minus sine t. So that's really interesting. Please don't forget to times 1 plus the sine t to the cosine t, and that's equals to the 1 minus sine, the square of sine t, and this one is equals to the cosine t plus cosine t times 1 plus sine t. So what is this? This is the cosine t, the square of cosine t. Do you remember? In the first one, the square of cosine t. So we can get this and this to get the cosine t, and that's what we prove it. And that's equals to this one. Okay, let's go to the next knowledge. This is the sum and difference identities. So first, we're talking about the cosine of difference and sum. So that's the cosine u plus or minus v equals to cosine u times cosine v plus or minus sine u times sine v. And this is a complicated process, so we can try it after class. And so I will deduce the sign of sum or difference for you. How to get this from the cosine part. And the sine u plus v, you can see this is just the cosine pi minus 2. Yeah, do you remember? I will check to you. This one, the cosine pi over 2 minus theta equal to sine theta. So this is equal. So we can get this cosine pi over 2 minus u minus v, and it becomes cosine pi over 2 minus u times cosine v, and plus sine pi over 2 minus u times sine v. Yeah, what we can get is from this. So it's just certainly just sine u cosine v plus cosine u and sine v. We can get this. So you need to understand how to deduce these problems. And also we learn the tangent sum and difference identities. And tangent theta equals to the sine theta equals to cosine theta. So this is just like this. But it also can be extremely 1. Both side denominator and this one, they both divide the cosine u and cosine v. It becomes the both dividers, so they becomes what we get from is the 1 tangent u get this. So that's really interesting. So if you have some problem, they give you that value, so you can use that one. If you give this, you can use this. Knowledge, we're talking about the multiple angle identities. We divided this part into 3 small parts. The first one is double angle identities. So let's look at sine 2 times u. So sine 2 times u equals to sine u plus u. So we can use the previous knowledge to solve this problem. And we can get the 2 times sine u times cosine u. And the rest of 2, we can draw inferences about other cases from one instance. And the next part is power reducing identities. We can also get all of 3 from the above one. I will do an example for you. Let's look the square of sine u. We can get this from cosine 2u equals to 1 minus 2 times the square of sine u. We get from this, as you can see, is equals to what I'm writing about. And after divide the 2, we can get the square of sine u is 1 minus cosine 2u over 2. So you can try the next 2 after class. The last part is half angle identities. Okay, this part we can also get from the previous one. I will do an example for you too. How to get this one? You can look back to about the square of sine u. The square of sine u equals to 1 minus cosine 2 times u. And you can get this because sine u equals to the plus or minus the square root of 1 minus cosine 2u over 2. And if you replace u to the half of u, you can get the result. don't remember to replace in both sides. You can get this, and you can get the final answer. You can try the next two after class. And the last part, law of sines and law of cosines. So this part, I will prove the law of sines for you, and law of cosine, we just need to applicate it to solve the problems. And how to get the law of sines, the pictures in the right hand. You can see the derived law of sines refers to the two triangles. I will draw it to you, in each of which we have drawn an attitude to side C. Right triangle trigonometry applied to either of the triangles tells us that, as you can see, sine A equals to H over B. And also in the acute triangle, we can see that sine B equals to H over A. While in the obtuse triangle on the bottom, we can see that sine pi minus b equals to H over A. But please remember that sine pi minus b equals to sine b. So in either case, sine b equals to H over A. And solving for H in both side equations, H equals to b sine A and H equals to A sine B. So the equation b sine A equals to A sine B is equivalent to law of sine. We can get this. And if we draw an attitude to side A and repeat the same step as above, we would reach the conclusion that sine B over B just equals to sine C over C. So putting the results together, we can get the law of sines. So that's how to prove the law of sine, and we need to applicate. I will give an example that angle A equals to 36 degrees and angle B equals to 48 degrees. And I give you a one side, A equals to 8. So you can just use the law of sines. But what circumstances we use law of cosines? For example, A equals to 11 and B equals to 5 and C equals to 20 degrees. I give you two sides an angle and an angle, so you use the law of cosines. So that's finished. Bye.